This is the second day of 4-4. Now we're going to be solving exponential and log equations. Probably one of the most important things to remember when you're solving these is that you have to isolate. You have to isolate the exponential power or the logarithm before you can do anything else. So, and if we're trying to isolate this power here, the e to the x minus 2, that's the part we're trying to get by itself. That means we first have to start by subtracting 5. So we're going to subtract 5 from both sides. We have 4 times e to the x minus 2 equals 65. But our power, the base and the exponent, still aren't by itself. So then we're going to have to divide by 4. So we have e to the x minus 2 equals 16.25. So our first step is to isolate. And we did that here. So we have isolated our can't see that. We isolated the base with the exponent, but now we have to actually solve it. So once you have it isolated and it's in exponential form, in order to solve it, you're going to switch it to log form. So the second part of this is switching forms. So we started by isolating and now we're switching. So to switch this to log form, since it's an e, we're going to do the natural log of 16.25 equals the exponent. Remember, this base of e is down here, but we don't have to write it. Natural log tells us that we have a base of e. But a log always equals the exponent. So it's going to be equal to x minus 2. So we're going to get x by itself, we'll add 2 to the other side, but not to the 16.25. You're adding it to the log of 16.25. And then you can find the approximation for that. Put that in your calculator. X is going to be approximately 4.79. So if they ask for an exact, you would say the first one, an approximate, the second. So keep in mind, we want to get the power, the base and the exponent by itself first. So we're going to add 228. And then after we get the power by itself, then we will switch forms. So we're going to switch to log form. This time we're going to use the common log because we have a base of 10. So we have log of 78 equals x plus 5. Notice how it's equal to the exponent. And then just like the last one, we have to get x by itself. So the 78 is inside the log. The minus 5 is outside the log. So we get x is approximately equal to negative 3.11. Same rules apply on the next one. We got to isolate the power. So the 5 and the 3x minus 2 is what we're trying to get by itself. So we're going to start by adding 10 to this really big number here. 5 to the 3x minus 2 equals 128,965 now. Then we have to switch forms. So isolate first, then switch forms. We're going to say log of that big number, 128,965, base of 5 equals our exponent. So equals 3x minus 2. So in order to solve this more, we got to get x by itself. So we're going to have to add the 2. Keeping the base of 5, all of this is together. The 2 is on the outside. And then we have to divide by 3. We're going to divide both sides by 3. All of this gets divided by 3. Now when you go to put this in your calculator to find an approximation, there's no button in your calculator that uses base of 5. So you have to use change of base that we did in the beginning of 4-4. So the first part of 4-4 talked about change of base. So in your calculator, when you're finding x, you're going to have to do log of 128,965 divided by log of 5. That's how we put this first part in. I would do that and hit enter before you add 2, that's what would come next. Hit enter, and then take that answer and divide it by 3. Okay, see if you get 3.10 approximately. That's what you should end up with at the end. But it's really important that you put them in your calculator carefully. All right, we're gonna keep going. Those were all ones that started as exponentials and we switched to logs. Now we're gonna go the other way. We're gonna start with logs, condense it down to a single log, and then see what we need to do from there. So we're using our properties that we did at the first part of 4-4. Here they're being added. So we can condense it down to a single log of natural log of 2x. Once we have done that, if you have a log on both sides, then you can just set your arguments equal to each other. 2x equals 8x minus 4. And solve a normal problem. So subtract 8 to get negative 6x. Divide by negative 6. And we end up with x equals a positive 2/3. Now, one thing you do want to check when you're solving is that your answer keeps your argument positive. Your answer doesn't have to be positive, but your argument in here has to be positive. All right, number 2, we're subtracting, number 5, the second one of these. We're subtracting, so we're going to have log of x plus 2 divided by 3, that's one of our properties, is equal to log of x minus 1. Again, once you get a single log on either side, the logs go away. And then you can set these equal to each other. From here we have to solve. And in order to solve, you have to multiply both sides by the denominator. So we're going to multiply this side times 3 and all of this times 3. So we have x plus 2 equals 3x minus 3. We're going to combine our like terms. So we get 5 equals 2x, divide by 2, x equals 2.5. Again, check to make sure it keeps everything in here positive, and it does. Now number 6 doesn't have a log on both sides. So on this one, we just have to isolate the one log that we have. So we'll start by adding 6. And then after we add 6, we'll divide by 2. So that we can get the log all by itself. The stuff inside stays with the log. So this argument is stuck with this log. All right, so just like we did with the exponentials, we isolate first, so that's what we did. Now we're going to switch forms. So since it's in log form, that means we switch it to exponential form. So to switch to exponential, we have to know the base. When the base isn't here on a log, that means it's 10. 10 to the 7th power equals x minus 5. To get x by itself, we're going to add 5. 10 to the 7th power means a 1 with 7 zeros normally, but in this case, since we're adding 5, it's 10,000,005. All right, same idea on number 7. If you haven't been pushing pause and trying these on your own, please do that now. See if you can isolate the log and then switch to exponential form to solve it. And then come back and check. All right, we're going to divide both sides by 4. So we have the natural log of x minus 3 equals 3. Then we're going to switch it to exponential form. The base of a natural log is e, so e to the 3rd equals x minus 3. Then we're going to add 3 to the other side. So we have x equals e to the 3rd plus 3, which is approximately 23.09. All right, number 8. 2 logs on one side. So hopefully when you see that, you're like, we have to condense that. We have to get it down to a single log. So we're going to take, since it's addition, that means we're going to be multiplying our arguments. So 4 times x minus 7 equals 2. And then after we condense it, now we're down to that single log, we can switch to exponential form. This is the common log because there's no base here, so that means it's a base of 10. 10 squared equals 4x minus 28. We know that 10 squared is 100. We're going to add 28 to it. So 128 equals 4x. divide by 4, and we get x equals 32. Okay, so number 9 is similar. See if you can get it started by condensing your logs and then switching to exponential form. Hopefully you started by log of x minus 15 times x is equal to 2. When we switch to exponential, we have 10 squared equals x squared minus 15x. And we see we have a quadratic, and when we have quadratics, you have to get everything to one side, so we're going to subtract that 100 over to the other side. And then we have to factor, so find something that multiplies to get 100 and adds to get negative 15. So we factor and get x minus 20 and x plus 5. Set them both equal to 0 to solve. X minus 20 equals 0. X plus 5 equals 0. X equals 20. X equals negative 5. Remember earlier when I said that you have to make sure that your answers are keeping your arguments positive? If we put 20 in, 20 minus 15 is 5, that's positive, and put a 20 in here, it stays 20, so that's positive. If you put negative 5 in, negative 5 minus 15 is a negative 20. That's not okay. So we'll cross out the equal sign. X can't equal negative 5, and we use the word extraneous. So it's an answer that we found when we did it correctly, but it doesn't work in our problem. All right, our last one, number 10 here. We have logs on either side, but we can't condense the one on the right side with the 3 because it doesn't have a log. So we need to get our logs together. So let's subtract the log of x base 3 over here on the left so that we have them on the same side, because then we can get down to having a single log and switch to exponential form. Since we're subtracting, that means we are dividing. So we're going to have 2x plus 1 divided by x equals 3. Then we're going to switch to exponential form. So 3 to the third equals 2x plus 1 over x. Always multiply by the denominator. So we have 27x, 3 cubed is 27, equals 2x plus 1. And then solve for x. So subtract 2x to get 25x, which is equal to 1. Divide by 25. So we get 1 over 25. All right, so you can see we use the properties from part 1 of 4.4 to do the solving in part 2 of 4.4.